we got two parallel plates. This plate is at 0 volt and this plate has some higher potential plus value, and the distance between two plates is 10.4 centimeters, and the sphere is placed here, which has charge minus 92.3 and 2.5 microcoulombs and mass of 30203 gram. Okay. The electric field causes the sphere to roll from one plate to another. The electric field causes the sphere to roll from one plate to the other. Alright. The electric field causes the sphere to roll from one plate to the other. If 18.5 millijoule work is done in moving the sphere, find the potential difference across the plate. Find delta V between the plates. Okay. So how do we define? We got two parallel plates. We don't know the potential difference. We know this is high, this is low. There is a charge placed, and due to potential difference, because it's a negative charge, it moves toward the positive charge. And when it moves, the work done on this is 18.5 millijoule. Okay. So how do we find the potential difference? It's really straightforward. We get potential difference is equal to our work done. Change in work or work done is defined as charge multiplied by change in potential difference. So we got potential difference, which is work per unit charge. So work is 18.5 milli, that is 10 to the power minus 3, and divided by charge, which is here minus 92.5 microcoulombs times 10 to the power minus 6 coulomb. So what do we get? Change in potential is equal to, if you divide 18.5 divided by 92.5, and we got 10 to the power minus 3 plus 10 to the power 6, that will be 10 to the power plus 3. Yeah. 200. We get 0.2 times 10 to the power 3, which is basically 200 volts. Okay. Yeah. So one thing you should keep in mind, because this object is moving from low potential to high potential. It's just like an electron moving from higher energy state to lower energy state. So there is a negative sign because it is emitting some energy. So some energy is coming out because the work is being done by the system. Okay. So that's why there is a negative sign. So we remove the negative sign that's come up with the potential difference, or you can simply say the potential difference is the difference between the value of two plates. So because we are finding the difference here, so it still is plus, because the difference is always positive. Find the electric field strength. between the plates. So now the plates show uniform electric field between them, and for uniform electric field the formula is electric field strength is equal to V divided by D. So V is potential and D is the distance between the plates. So potential difference is 200 and the distance between the plates is 10.4 times 10 to the power minus 2. Okay, so 200 divided by 10 to the power minus 10.4, and this will go up and be multiplied with 10 to the power 2. So 10.4 divided by 200, what is it? What's the answer? 1293. 1293. What will be the unit electric field is force Newton per what do we got? Newton per coulomb, force per charge. Yeah, so that will be the electric field strength. You can also use the unit because here is volt per meter, so you can say it's volt per meter. But the basic unit of electric field is Newton per coulomb, and you can use both the units whichever you want. But if you are deriving it from this formula, yes, it's volt per meter.